Okay, so you want to learn, but this time I'm actually on time and not late. But this happens only because I rescheduled for 5 minutes. It was supposed to go on 9, but then I realized that I did not prepare anything. So I shifted the start of this virtual content by 5 minutes, and I think it's more natural for contests to start like at 5 past something. So we are actually good here. It's one div to run that I missed because of my job, and I decided to like I can have enough runs, so I will solve it virtually today, and maybe my friend will join us as well. I should actually, yeah, it should be good. Yeah, cool. Okay. Problem A, add and divide. You have two positive integers A and B. You can perform two kinds of operations. Let's start with reading A and B. So A gets divided by B and B gets increased by 1. Find a number. Make A equal to 0. And we actually have 100 test cases. Be honest with you, I don't know what is the idea straight away. Like clearly, if b equals 1, then we want to add 1. Otherwise, I guess we can just divide by 2, and that's going to be the fastest way. Because like, what is the point? Okay, so let's actually have our counter. Oh my gosh, I forgot that when you press up, but there are no commands, you haven't entered the command, it does not get stored. That's good. What do I mean actually? Sure. So we are wrong for this test case. So it is actually beneficial to add 1. Okay. Like more times, right? Yeah. So so it's a bit different, I guess then. Yeah, let me just quickly fix this template issue. So it's not always optimal just to divide by 2 if you got to. Sometimes you want to add to extreme and only then divide. L. How do I actually know what is best? Like that's not clear. Okay, let's have it. It's quite confusing. Did not expect it to require honest and smart. Look at me now. I am clearly failing. Maybe answer, maybe like optimal B is always up to 10. I don't know, up to 100. Uh, yeah, I'm guessing this is like very crazy max band. What if I actually do something like that? No, okay. I'm just so stupid. I really don't know what is the expected way to solve this problem. It's just not great. I mean, there's clearly no sense in increasing B after you divide it at least once. So I'm assuming that you can get away with something like this. What? Yes. Okay. 4, 9, 2, 12, 3, 1. Yeah, I'm pretty sure that's not what they wanted, but I'm going to submit it anyways. Like the assumption here is that optimal B does not take more than 100 increases. And I guess it's true because like you always can just within 30 operations, you can always solve the problem. You just get to 2 and then, yeah, okay. Oh, so that's actually what they expected, okay. Replace and keep sorted. Given a positive integer k, two arrays are called k similar. If they're strictly increasing, they have the same lengths. All their elements are positive integers between 1 and k. Oh no. Wait. What? Oh, so they have the same lengths, which may be smaller than k. Okay. How a given integer strictly increasing array a and q queries. For each query, you're given two indices. Your task is to find how many arrays B exist such that B is similar to array from L to R. What is that problem? No test cases for this problem. That's pretty annoying actually. Like because I'll have to test it manually, right? What is this? Yeah, I really should just get a test script instead of doing this manually. Yes. Oh wait, actually, here we clearly have a loop like this. And if you think about it like this, like they have to differ in exactly one position, which means that we want to know how many ways there are to alter one element in some subarray to keep it strictly increasing. Which I'm guessing is more or less the number of free elements. Not exactly, not exactly. Like suppose that we have an array which looks something like 4, 6, 7, 8, and we're interested like in 9 similar. So what we can change in this array, like this element can get from 1 to 3, 5, right? And this can get to 5, and then this can get to 9. And the point is like every integer in between 4 and 8 gets used twice. So we have minimum, we have maximum, and we have length. Len. And I'm guessing there are capital M minus small m minus len. Sure, minus len plus 1, 3 elements in between. So that gets multiplied by 2. And then how many elements do we have? We have k minus m elements that are here. And then we have m minus 1 elements that are smaller. At least that's what I think so far about this problem. Now we actually have to work carefully with indices. So I'm guessing we have to, yeah, I want to decrement both of them. So they are actually both valid indices at the moment. Smaller can get a li, bigger can get a re. And if I just give right minus left, then it's maybe exactly the length that I want. Now I will want to output something like, I hope I do not like misunderstand the problem drastically. That would not be fun. Okay, so far so good. 89769. Should I care about overflowing anywhere? I may actually care. I may actually care. Oh, these are indices, but this can be quite big in this. Okay. I'm pretty sure I did not introduce any bugs by doing just this. So. It's exactly the same, right? Is it the correct? Yeah, okay, whatever. I mean, that's easier than the previous one. Or maybe I was just thinking too long about the previous one. A foreign mod, a pair of positive integers, hello darkness, my old friend, I guess, is called special if a quotient is equal to the remainder. Given two integers x and y, number special pairs such that a is up to x and b is up to y. And these are huge. So what do we have here? They say that this equals to this, right? What does it mean actually? This is quotient, right? And this is remainder. We know that A is quotient times B plus remainder. So if we substitute the first into second, what are we going to get is, well, we're just gonna get that they are equal, right? Or better yet, we substitute remainder. Well, because remainder is between 0 inclusive. No, not inclusive because then we, and B also not inclusive. So for like, clearly we want this, and but also we want B to be at most Y, and at least one, of course. I'm trying to think what is the best way to count this. I'm kind of guessing that the best way should be over R. Yeah, I'm pretty sure the way our R is good. Yeah, I'm going to explain it in a second. So counter is going to count our stuff. In the end, we're going to output counter. So remainder should not be 0. This kind of condition should hold. Now you see minimum B is R plus 1. And maximum B is minimum of Y. And like here, what we actually have is R times B plus 1 is at most X. So you can divide by R and substitute 1. So B got to be smaller than the minimum of 2. Smaller or equal. Keep in mind that this is quite like at most square root of X values of R are going to be tested. Because then like the smallest B will already don't fit. I don't know how to say it the right way in English, sorry. Actually, like, we should be a bit safer here. I'm guessing that's what we can do. Then we have 100 test cases. Each of them works in square root time, which should be fine. One zero two three five 141 53,384 160,919 36. I don't like this. Neither this, of course. I'm pretty sure I did not. Okay, max. Really? Do you complain about it or do you complain about what? And 23. How do I do it? Should I do it like that? Yeah, apparently nothing changed, so I guess. Okay. Yeah. Okay, never mind. Multiples and power differences. Given a matrix A consisting of positive integers and has n rows and m columns, want to construct a matrix B consisting of positive integers should have the same size as A, and the following conditions should be met. So all entries are at most 1 million. Bij is a multiple of Aij. The absolute value of difference between numbers in j's pair of cells in B is equal to k to the fourth. What the? But that's not true. Oh, okay, so Aij is at most 16. Then now we are talking. So that's what we did. What are the 6 powers that we, or 4 powers that we know? Up to 1 million, of course. It looks like 1, then 16, I think. But that we have 16. 3 to the 4th is probably like 81 and 256 and such. I don't really like it. These are strange problems, I must say, but at the same time, it's kind of good that they're unique. I'm not saying that unique is necessarily good, but yeah. I think I is up to sort of here. Yeah, no, okay. That's the most stupid for loop I ever wrote in my life. Okay, so all integers are up to 16. And I kind of want all differences to be the multiples of 16. Is it possible? Is it? Wait, I can't afford. That's pretty bad, actually. What was LCM up to 16, actually? Then we can't just make them all equal to LCM because we want positive things, right? Can't be a coincidence. And K should be at least 1, and it's not clear from here. This number clearly would result in all zeros, which is not really interesting. All zero difference. Like here we, for example, here we have to make them different on purpose. It's not clear what we are expected to do here. I guess we can do our bets and can take a look how our friend is doing, if he's doing. Okay, so he's doing not bad. He started 5 minutes earlier and already solved first problem, which is good. Second thread is massive, I must say. Just nuts. And it has to do something with the fact. Probably we don't want to make them like divisible straight away. I don't understand what we are supposed to do here. Why? It's only D from div2. Well, why am I even thinking? That's not right. All those instruction problems. So it is equal k to the first. Let's say that Bij are actual like multipliers. So we have something like that. As we all know, if they are multipliers, then we have k divisible by at least GCD. And GCD can be 16. GCD can be 11, which is not great, because then we would have to take 11 to the first. Let me quickly check how bad is 16 to the first. That's not something you want. I mean, 13 Even 15 to the fourth is like, well, what if we got two numbers that are adjacent and both divisible by both 15, right? And you need their difference to be not zero, but then divisible by 15. And because it's first power, then it's at least this number. It's not really cool. That's really cool. I like, okay, having one difference is not a big issue. If we just compute GCD, we take the first power, and we are done. Like the real problem is suppose we are filling our matrix from left to right, and then we have two of them, and these are actually already have predetermined values. Actually, even here I have predetermined, so I have like B1A1 minus XA2 should get K to the fourth. Well, like what the? So I'm given some number. I have to find number that is divisible by A2 and its difference. Wait, I can just walk 16 numbers, right? For every cell, I can just try the powers. So then I'm going to phrase the issue like B1A1 plus or minus K to the fourth should equal XA2, from where I can derive like this, and A2 is at most 16. So we clearly can make it divisible by 2, by 3, by... What if this got wrong remainder? I mean, because we have force powers, I'm not getting all different remainders. So strictly speaking, I don't have to get the result, guys. Why is it so complicated? And if you have two, it's like, well, yeah, if you try to satisfy two conditions to the left and to the top, upwards, right, it becomes just very bad. Basically, you need B1, A1 plus or minus K1 to the fourth to happen to be equal to B2, A2 plus or minus second to the fourth. Oh, actually, am I right that it fits? Huh. Yeah, I'm just being stupid. What am I even doing, people? Like, of course. Like, yeah. I understand all this. Same second thread. I actually was reverse engineering him. I know how you think. No, actually, I don't, but I realized that if it's solvable in such time, then it's got to be very simple. And now my idea is the following. So I start with this. This is clearly divisible by everything. Then what if I just walk in chessboard pattern? Guess this is the way to do it. I'm not exactly sure like what half of the cells I'm taking, but I don't care either way. Oh, only if this happens. That's the most stupid function that I ever wrote in my life. Well, at least we got rid of the most stupid cycle, the most stupid for loop action. So I want to replace this and this, and then I don't want to replace this. This does not matter. This may matter, this may matter, does not matter. Okay. Do I have everything ready? Is that lazy? This is even, this divisible by 3. The difference is 16 and 16. Understandable. Have a nice day. That's all this test case can say to me now. So this is actually like negative 16 to the first. I can actually add, and this always the same. I don't know actually why I'm adding, because it's like, it's worse. Yeah, we got something quite plausible. Just yeah. Chessboard patterns rule. Yeah, really cool. Nail is insane. Problem E, move and swap. Move and swap. It pretty much sounds like C++ idioms. No, I mean, move semantics, swap idiom, something like that. I'm pretty sure the problem is going to be like completely different because, yeah. We got n minus 1 integers a2 and an, a2 through an, and true with n vertices and rooted at vertex 1. Okay, the leaves are all the same distance d from the root. Recall that a tree is connected to undirected graph without cycle. The distance between two vertices is the number of edges and the simple path between them. All non-root vertices with degree Well, so root is not leaf, okay. Vertex is connected by an adjoint distance of f from the root is greater than distance. Okay. A red coin and a blue coin on the vertex 1. R is the vertex with red coin and blue. Take D moves. Moves red coin to any child of R. Moves the blue coin to vertex B prime such that distance B prime. Also, like blue coin descends level by level, and red coin descends to child. So I can also swap the colors. Well, that's sick. There must be some DP on the tree. Yeah. What did I just wrote? Yeah, I meant to write this, of course. Great. No, actually, means that there is an edge between vertex I and how did you call it? Vi. Okay. Pretty sure we have to decrement Vi. No, I think this is also we also right. Okay, well, actually, there are clear problems with DP, clearly, because we cannot have like as a state pair of vertices, because it would result in us having quite a difficult time enumerating all pairs of 10 to the 5th elements. And I also lost D somewhere. Wait, what is D? Where is D in the inputs, man? No, like really, what is D? Is it the depth of the entire tree? Yeah, I don't understand. Yeah, gifts are cool, but what is D? Is D the depth of the tree? Oh, the leaves are all the same distance D from the root. Okay. Apparently, I can't read. Well, it makes sense that you can't make more moves, right? Let's think, like position of the red coin matters, position of the blue coin does not matter. Yeah, so for each vertex we're going to compute dp what is like the best score, given that red coin is in it. We can compute it from leaves to root, from root to leaves. I don't really care. And the point is, whenever you have a red vertex somewhere, blue, on the same level, blue is going to end up like anywhere. So blue can always be at max difference. I don't really understand where the blue can be. Okay, so apparently it's not easy. Okay. There should be something like that, but you got to be careful when thinking about it. Maybe layer DP, something like that. Anyways, problem F copier. Yeah, because like people are clearly solving this, and I'm clearly not solving E. You're given an array of integers b1, etc. bn. An array a1, an is a hybrid if for each I from 1 to n, at least one of these conditions is true. B is either the element or the prefix sum. Find the number of hybrid arrays. What? What? Oh, okay, so that's the other way around, but it doesn't really matter, does it? For a second, I thought that we want to find number of BI arrays, which clearly does not make sense as a F, as problem F. Well, at least I'm still misreading statements, but at least it does not take all this long to find my mistake. Yeah, not very efficient way of doing this. How's our friend doing? He's doing not bad. He solved C already. Good. Well, but he started 5 minutes earlier. I'm pretty damn sure that this is DP. Only one. Because you see, what are the conditions actually? Like this or this? Right? This. And then we need this, right? Second thing that we are going to need is something like that. And like, what are the options for A1? If you rewrite it as A1, you either get this or this. So pretty simple so far. right? But then we run into problems. Because the second condition says, so here you actually have like a clear value. Here you have two options, but A0 is determined in uniquely. That's important. Here you either get B2 equal to A2 is either B2 or A2 is equal to B2 minus A0 minus A1. This prefix sum may or may not equal B1. What are options in terms of B's? Let's focus on this. Here we have simple options. I think we're going to notice the pattern pretty soon, but I can't tell. Like here it's clear B0. And then it's A1. And A1 can have two different meanings. E1 can be simply equal to B1. Or A1 should just break like this. Yeah. E1 can be equal to this. I'm just going to substitute it here. And you can see what happens. B0 gets discarded from here. And I feel like this is better written this way. Or this way. Now I'm pretty sure that you can recursively prove the following. This is either this, or this is equal to this, or this is equal to this, or you get the trick, right? So now you can just maintain these values in a multiset. Yeah, and you just add and you just multiply by the size of the multiset. What happens? Okay. That's AI equals B0. It's equals 1. Actually, this is not clear. And these values do not get directly from here. You have to decrement everything by B2 twice, and then add B1, B3, right? Point here is that we expect the following to happen. I haven't actually proved it. You may have noticed that I haven't proved it, but I'm pretty sure it's correct. So the idea is that like these values have to be connected in order for us to bash it with multisets. It's not like very stupid. It's also B3. But hey, like B3 is equal everywhere, right? So what do they differ? Like B3 is actually different from 0 in prefix sum from B2 to B1. And here you have, yeah. You are happy with prefix sums of B. So that these are not the real values of AI, okay? Just to clarify. The correct expression is that this is and then plus, yeah, that's the point. Something like that. Or I'd actually don't care. So I can safely do it like this. Uh, right. So at least multisets can't be hacked by hash collision, right? Because I was pretty angry when I found out, but I don't understand. What exactly is wrong? Understandable. Okay, okay. Just for me not to forget, so remove them. 1, 2, 3. Wait. Are they dependent? Are they actually dependent? Yeah. The point is that this is different. Because this is different. Okay. So if A1 is equal to this, if A1 is equal to this, and we get this. And if A1 is equal to B1, then we can get this. And this we can get in both cases. We should have thought it through. Okay, how much time? Okay, we have 1 hour left. I really thought it through. So B0 is equal to A0. B1 is either equal to A1 or B1 is equal to A1 plus A0. Here we get A1 equal to B1. 0 equal to B0. Okay. And then we have B2 is equal to A2, which is kind of on its own. Or we have B2 equals to A2 plus A1 plus A0, which can mean two different things. Given that h2 is equal b2 minus a1 minus a0, but a1 and a0 can be different numbers. So here you get an option of b2 minus b1 minus b0. And here you get an option of, yeah, and I think I'm not speaking straight into the mic now, but so please forgive me, but I kind of focus. Also, you have to think whether these two are equal and not that, so that's pretty bad for me. But that's problematic to keep everything. I must say that's quite problematic. I still kind of want to use the same idea, I just have to think it through. But now it depends on the history. What is that? Really? And that's insane, all this smart. I don't understand this problem properly. Uh, hmm. You won't need it here. Didn't need it here either. Just... Yeah, you see, what is the point? I kind of want dp to start how many possible values for AI are there. Because like what we really know, the previous condition was incorrect. But we're like 100% we know this. Right? It's either BI or BI minus all this stuff. Maybe even simpler, like, let's think about this. What are the possible values of this sum? So a prefix sum at I. Prefix sum of A can be either BI plus PSA I minus 1. Or just BI. I suppose that PSI is a map. So it actually stores like how many ways are there to get some prefix sum? Maybe actual answer. This actual answer is something like this. Then you want to increment all keys by BI and add 1. No, and add this continuation does not depend on the history of many ways to get here. But for 0, I am thinking that you can continue with this like anything you had. So PSA adds I do really not care. I just don't understand. What is PSA? Verification, the number of ways. The problem, okay. So if we set ik, there's a number of ways to have the prefix sum of first I elements of A equal to k. It's number of such ways. And what is this? This is either so a minus 1, k minus bi. So okay, let's consider this quantity. How much time do I have now? No, I don't have to code anything yet. Now this quantity, if it is reset, it can get this value, or it can get some normal value. Or it can remain the same. Or it can get this value. Well, it's not a big of a problem. So I'm going to be not very smart with names, and I'm going to call this prefix sum difference. Self-explanatory. This can get from any value. Should get the sum, the current sum of all values. Well, that's not going to be easy. Well, sum starts with 1. Oh, actually it is. Because well, sum plus diff is equal to p with b. Yeah, okay. If I actually subtract this from this, I end up with a bit nicer condition. It's map. It does not have that problem. Don't trust you. I don't trust you anymore. Should I just print a Warsaw? I did not look up where. Because this happens here. No. And the point is, with this value, you can continue anything. Otherwise, the value stays the same. There's only one way to stay the same. We are quite close, I think. bi equals 1, plus b equals 1, difference equals to -1. Is it true? Wait. Do I actually want this? 516 for, that's not what I wanted. Maybe I want this here. 38223 1. Good job, well played. Int, a number of test cases, size of the array, no more ints for us. While sum is always modded, this does not have to because it's modded at this moment in time. Difference can be negative actually. Good to go. Good job, good job. Yeah, quite slow, obviously, but still not bad. Okay. And Anton is just a madman. Tom is just a madman. Second thread spent 20 minutes on C. Well, it happens. Who am I actually with my timing? Right. How much time? 35 minutes to figure out this 3DP DP. I'm gonna take a short break and I'll be right back. Yes. I think I actually like have very hand-wavy idea of what I should do. I'm not sure if it's implementable in half an hour, but we'll try. There's not much anymore. Okay, so actually this may help us. Because of the following, like all edges go. The tree is already topologically sorted, right? That's not enough. You would like it to be like actually a sorted layer by layer. What I think, like here we computed distances from edges, right? Now, what we would like to do is we would like to group vertices based on that distance from roots, and then process in a sorted order from the highest, from the deepest to the least deep. Because like the idea is still the same, that you can have a DP state at some node corresponds to best score from now till the end. If here we have a red coin, because why? Like optimal position for blue coin is either max value on this layer or min value, right? But there are some, like what is the transitions? Obviously you can move red coin to parent, right? And you can move blue coin anywhere. But moving to parent is not always effective. How can you move red coin not to parent? You can move red coin not to parent if you move it up and then swap. You swap with the blue coin. Here we have ourselves groups of different depths. Now we want to process the groups in reverse order. That's hard. Yeah, you have to like layer variable. You need some sort of layer variable. But then like this part is going to be easy. Just dp at 0. Actually, this part is questionable. Very questionable. Not great. Here you want to somehow update. Yeah, I'm going to just leave 0 for now, but here you want to actually update. Maybe this layer. New. Oof. That's very broad words. Like the idea is that transactions to parent are easy. Now, what is not easy is swaps, but swaps only come from pretty simple blue, from only like limited number of placements of the blue kind. So swaps should not be a great problem because they generate like, they are almost the same for all vertices. I'm thinking of something like that. We probably want two variables. Because it makes sense, like the furthest from here can be either max or min. Or maybe updates happen here. To be extra sure. We can afford something like that, layer min. It's something like that should be very useful, but I don't know what exactly, and it's kind of not good. I lost faith in myself, to be honest. It should be something like this, but I just can't figure it out. Oh, that. Maybe what we need is actually some sort of context like this, where you first say like this layer, I mean this layer max. Here you get this and this. Initial 0, so it's okay. Where did all this space came from? So if this thing corresponds to what happens when you go from from W to V, like from child to parent. So red coin just moves from here to there, and it's good. And it's good. No, actually, like this part is like everywhere. I should originally do this and then do this. Yes, it makes more sense. Red coin for the next layer may be located in min or max also. That's not this. That's not this. This is different. We want index. Yeah. I know. This is smaller than this. First thing we want to assign this. Come on. That's the wrong way around. I suppose we gain from min to max or from max to min. It should not match actually. problem. Here it's important to check against this. That's the same check, to be honest with you. Something here. I need parent array or something. My brain is melting at the moment, so forgive me if I do anything stupid. I most definitely do. You get to deal with it now. Yeah, like something like this, but clearly this is not going to work first try, and we are going to spend the remaining time debugging this stuff. I think I did not even copy this test case. Yeah, first time I just did not copy the test case at all. I immediately thought that this is not something we're going to solve. Yeah, is it? 17, line 17, 3i pushback. I actually have clear screen here. Why did I? Understandable. I talked too much on camera. I actually had a like 3-hour long math lecture right before it, where I'm as a lecturer. That did not go easy, must say. I thought I never hour count, actually. But then it broke, so it's clearly wrong. But what exactly is wrong? Okay. Okay. And it does not happen if there is nothing here. Like, actually, this does not matter. Let me quickly check. Wait. Wait a second. Do I actually have to restart tree myself? Are you crazy or what? Oof. Who the hell gives input in this order? Am I right that this is linked to previous? This is just somewhere. Oh man. Nah. No. Nope. Not even close. Like clearly this will have to, right? The group, but graph. This is completely unnecessary in this problem. It should not be my problem like this. Or maybe I missed something. This is just annoying. Currently, distance to double distance. What the heck? Line 11. This should be done here. Just randomly breaking. Cool. Cool, not cool. Okay, suppose I comment this out. Like, will it fail? Understandable concern. So the problem is somewhere here. Push this back, push this back. Does it mean that I have to do it like that? Or did I read actually the wrong thing? Or because now it's not going to work, but it's fine. The heck? Oh, DP is obviously of the wrong type. Maybe it's a greedy, and that's a greedy that does not work and not int. Yeah. Yeah, I think it's greedy that did not work and not something else. Yeah. I think this part is correct. And this is just a greedy that does not work because you want to go to different prefixes. You want to go to whoever has the best DP value. Am I safe if I write like that? There's no way I am, replacing random things with random things is not a good idea. I guess it will actually work, but I don't want to try it. No, we are not yet in the here on time, right? Right. Yeah, I think something like this will work, but I have no idea what exactly. Also, I messed up my critical test. And this is actually the only place where I needed to replace them and not replace them. Okay. Okay. I'll try to solve it later on. I'm not sure what will be the result of these attempts. Not perfect, but not bad, you know. Yeah, it failed like it failed just tests, not system tests. Okay. Like I think it's not bad. My friend also did quite good for his rank, I'm thinking. Okay, I'll debug this later. And we actually want like not max index of element, but max index of DP. Maybe one this, that's like, it makes more sense. I have no idea why I decided to do it here. Yeah, I'll just debug this later. The last thing I want to check is this wall contest is rated VC on my Discord server, which is we both get quite good delta, I'm thinking. We are both like top on the server, okay. I don't know what this is, maybe did not skip E. Yeah, probably, definitely did not skip. Okay, so I think it is all for our practice. I'm going to discuss with Andrew later. I'm going to discuss with him right now, and then maybe I'll upsolve E and we'll talk later. Yeah, so thanks for watching. Bye bye.